Before we start this video, a large thank you to Yosef, David, Jeff, Clavix, a name I unfortunately cannot pronounce. Thank you for the support, my friend, Ocean Man, and Dalagon for their support on Patreon. I hope you guys enjoy the video. And an immense thank you to Halo Burner and Sora Stratos for their immense support to the channel this month on Patreon. I hope you guys enjoy the video. Hello everybody, and today we're going to add on to the combat stance state, and we're going to conclude that mostly, and we're going to also add the attack state. So I'm going to go to my enemy animator, which is called Undead for me. I'm going to add some attacks. If you guys want to use the same attacks as I am, this animation kit is live on the asset store as of a couple days ago. If you got your own, awesome. Whatever you want to do, just drop in whatever attacks you want to use right now. I'm going to use Zombie Light Attack 1 and 2. I might use the swipes here too. Actually, just 2 attacks this one. We'll keep it very simple for now to get the logic actually out there and working. So I'm going to rename my attacks to something very simple, and I'm going to translate them back to the empty state. I'm just going to name them Attack 01 and Attack 02, just to keep it very, very, very simple. Most enemies in games like this usually just have somewhere between 2, 3, or 4 attacks, so we can just use Attack 1, 2, 3, 4. Okay, so next I'm going to go over to the data folder. I'm going to right-click, create a new folder. I'm going to call this AI Attacks or AI Attack Actions, whatever you prefer. I'll put actions here to keep it in the same naming conventions as our scripts. Going to open that up, going to create another folder inside here. I'm going to call this Undead because this is specifically for this character. I'm going to right click, create AI actions, and then we're going to go to an attack. Okay, so likewise, I'm going to keep the name very simple. Just Attack 01 is enough. I can duplicate that and make it Attack 02. And I'm going to fill in Attack _ 01 in the attack animation section to match the animation name of this right here. Here's the attack, by the way, if you're curious. So one is like a left-right claw, and one here is a swipe. So I'm not going to set up combos for this video. We're going to do that in another one. We're just going to get the attacks working, and all of these angles and distances look fine to me. And the minimum and maximums are all good. So it's going to rename this Attack 02, duplicate the original Attack 01. Now let's go over to our dummy. I forget what I called them. Here we go, Dummy 01. I'm going to rename this to Undead Dummy 01. And I'm going to go down here now into the AI States folder, and I'm going to right-click, create AI States, and we didn't actually make our combat stance state, so let's do that right now. And then inside the AI Character Attacks list, I'm going to put 2 entries here. I'm going to place an Attack 1 and Attack 02. Alright, that's good. Now we can go over into the scripts folder. And then let's go to the character, the AI character states, and let's right-click, create a new script called Attack State. Alright, so we're going to bounce back and forth between the attack state and the combat stance state. There's not much left to do on the combat stance state, but there's a couple things we're going to add. So let's start by deleting the start and update functionality and adding in our namespace as is per tradition. And then we can start writing some logic. So what do we need here right away? Well, first we need this to derive from AI state. And next, right up on the top here, I'm going to start by making a couple variables. The first one is going to be hide in inspector. It's going to be public, so it can be accessed from the combat stance state script. And it's going to be an AI character attack action called current attack. And this is the attack we assign from the combat stance state. Next, I'm going to make another hide in inspector. A public bool will perform combo is equal to false. And we're not going to mess with this right now, but we are going to set the logic so it's going to be mostly there when we get around to doing it. Next, I'm going to make a header for state flags, and I'll put a header up here too, even though it's hidden in the inspector and we can't see it, just to keep it nice and neat. I'll call the header current attack. So back here in state flags, we have a few things we need to keep track of. Let's make a protected bool in case we ever want to make a class that inherits logic from this in the future. Let's call it has performed attack is equal to false. Let's make another protected bool, has performed combo is equal to false. We need to reset these every time we leave the state. That's very, very important. Next, I'm going to make a header. I'm going to call this pivot after attack. This is optional. So basically, if you want your character to pivot after they perform an attack to face their target again, check this is true. If you want, you can do it by default. You don't have to put a check here. I like putting a check because some enemies I don't want to do that. So, pivot after attack, defaultly set to false. Next, let's override our tick and let's actually start writing the state logic. So, the first thing we have to do is check and make sure we actually have a target. If we don't have a target, then we're going to return to the idle state again. So we do that by saying if AI character combat manager current target is null, return, use the keyword return here all the time, switch state, and we pass the AI character and then the state we want, which is the idle state. Cool. So this will make it so you don't ever get caught in a place where if your target gets deleted somehow and you're mid-attack, you don't get any weird errors if you're about to attack. So next we need to make a line of pseudocode here. Rotate towards the target whilst attacking. So that's basically tracking for some portion of the attack. There's going to be a specific set of frames where you can actually rotate towards the target while you're attacking. Next, set the movement values to 0. It's just nice to do that, so you make sure you're not actually getting any additive movement while you're in the state. You don't need to do that, but I like doing it. It's just safe. If AI character current target is also dead, while I'm thinking about it too, we can switch back to the idle state. You don't need to attack a dead character. And then right below here, we could say if will perform combo and has not performed a combo yet, well then you would perform the combo action. There's something we need to check in here yet though that we can't at this very moment. So for now, I'll fill the logic that we can. We could say if the current attack dot combo action does not equal null, then we can simply perform that action by saying current attack dot combo action dot attempt to perform action, and then we set the has performed combo to true. Now we're supposed to check here if the AI character is capable of performing a combo, because remember we're only going to allow that in certain frames of the attack, but we'll come back to that when we actually add in combos, which we might do in the next video. If not, definitely the one after. Okay, so next, I'm just going to make a comment up here for this. We're going to say perform a combo. So we will come back to that little chunk of code there very soon. So next we're going to say if we have not performed an attack, we want to check for a couple things. First thing I want to say is, do we have an action recovery timer above 0? We don't have this variable may yet, so what is this? Well, if our recovery timer is not at 0, it means we're still recovering from an action, so we're going to return and wait. So let's go make that timer. Now you could, I'm going to go back to the AI character manager, I'm going to make a public combat stance state variable, call it combat stance, and I'm going to make a public attack state variable and call it attack. Now you could put the action recovery timer here, perfectly acceptable if it makes the most sense to you, but since it is kind of a combat thing, I'm going to go ahead and put it in the AI character combat manager. So you can just put a header here for recovery timer like so, just so you can see it. If you always want to check on the AI character manager, if that's your main script, you always come back to the inspector, that's cool. I just like having everything in a certain place, so I'm going to put it over here under the AI character combat manager. So I'm going to give it its own header. It's not going to have anything besides this one variable, but you can get kind of creative with this. For Nephilim, for example, I have a multiplier. So you have an action recovery timer, but then I have some characters who recover from actions faster using the multiplier. And the multiplier can be changed during other states or certain actions they're performing. But we're going to keep it simple for now. So just the action recovery timer. I'm going to make a public void handle action recovery. And inside here, I'm going to say if action recovery is greater than 0, then we're simply going to make the action recovery timer go down with time.delta time. So every second it counts down 1 second. And I'm also going to grab the AI character manager variable here and copy this and make it require that we pass an AI character. And I'm just going to say here, if AI character dot is performing action or is not performing action, sorry, then we count down. So if you are performing an action, you don't want to actually modify this timer and count down. Otherwise, we're going to say action recovery timer minus equals time dot delta time. Now I have to call this in an update function. So let's copy the name of that function, go back to the AI character manager, and we actually only have a fixed update. So let's override our regular update and keep it the same by calling the base. So base.update. And then right after that, we're just going to say AI character combat manager dot handle action recovery and pass this as in the AI character manager script. All right, let's save that. Now we reference the AI character combat manager dot action recovery timer if it's greater than 0, and again this is on the attack state. So if we have not performed an attack and our action recovery timer is greater than 0, then return this, which means you're just going to go back to the top of the state again and wait, and it's just going to keep going back up until we can actually perform this action. So likewise here we can also check to see if we're being staggered or we're performing any kind of actions. So if you're playing a damage animation or what have you, so we can say if AI character dot is performing an action, then return this, go back to the top and try again when we're not performing an action. And then right below that, we can write some logic for the attack itself. So we can say has performed an attack is equal to true. And then we can actually play the attack by saying current attack dot attempt to perform action and pass the AI character. So let's actually give this its own function because we're going to add one more line of code to that. And if we want to add anything to it in the future, it's nice to keep it clean and separate it. So let's make a protected void for perform attack. And then inside here, we're going to make it require an AI character manager, call that AI character. Let's copy and paste the 2 lines of code we just wrote. So has performed attack equals true and current attack dot attempt to perform action. And we're going to add one more thing inside of this right after we play our current attack. So let's call perform attack in there. And then right below current attack, we're going to say AI character combat manager action recovery timer is equal to the current attack action recovery time. So basically, whenever you perform or whenever the AI performs an attack, the recovery timer is set to the recovery time of the last attack they performed, and they cannot do another attack unless it's a combo until that timer reaches 0. And lastly, we're going to put in return this. So we go right back up to the top. And in the future, when we have the combo code finished, it's going to go back after we attack. And if we can perform a combo, we're going to do that. And if not, it's just going to lead to state when it gets to the bottom again. And we're going to go back to the combat stand state. All right, so right below here, we're going to say if pivot after attack. We're going to say AI character combat manager pivot towards target. Use that function we made and pass the AI character. So now you'll pivot after you attack if your character is out of the field of view range. And then we're going to return switch state. We pass the AI character and the AI character combat stand state. Okay, cool. Still some stuff to do. That's the bulk of the logic here now. So let's save that. Now we're still going to need to set the movement values to 0 here. And we're going to need to rotate towards the target. I'm going to make a comment here too. If we can combo, because we need to check what frames the AI is actually able to combo. And for now, I'll just comment out this code because we're going to come back to that. And we'll finish that in a separate video for sure. So let's set the movement values to 0 here by calling AI character animator manager update animator movement parameters 0, 0, and false. We're not sprinting. Okay, so what's next? We got the rotate towards target whilst attacking, and I believe we have the rotate towards target still in the combat stance state too. Yep, there we go. All right, so we're going to make 2 of these functions. One is going to be for rotating while you're attacking, so that ignores the nav mesh agent. You're going to just focus on the target. This will allow you to basically have your AI attack targets and potentially like fly off a cliff if they miss or whatever. And the other one is going to be for rotating with the nav mesh agent when you're in your combat stance state. So let's start, and I'm going to delete this here now because we've already checked for the combo action on the attack state, so we need to check here too. I'm going to say AI character attack, as in the attack state, current attack is equal to, I call it selected attack or current attack. So we're going to pass the current attack here, its current attack, to the attack state. And we're going to ignore roll for combo chance right now. And then we're going to switch state to the attack state. So this is again on the combat stance state. If we don't have an attack, get an attack. Otherwise, set the attack on the attack state and switch states to the attack state. All right, cool, looks good. Now let's handle these rotation functions. So we can actually write these on the AI character combat manager as well to keep it all in one place because it can be used in multiple places. So let's make the first one. I'm going to make a public void. I'm going to call this rotate towards target. Actually, sorry, that should actually be rotate towards agent. So I'm going to change that right now. Rotate towards agent. Make it require an AI character manager variable. Call it AI character. Open up some curly braces here, and this is very simple. So I'm just going to say if AI character network manager is moving value, then we're simply going to copy the rotation of the nav mesh agent by saying AI character transform rotation is equal to the AI character nav mesh agent transform rotation. Okay, cool. So we got this. Let's copy this function again. We're only for the name of it though, and we can actually come back before we do that and call that here. So let's go to the combat stance state and just call AI character combat manager rotate towards agent. Agent again is in nav mesh agent. Okay, that looks good. Let's go back. And the second function is going to be rotate towards target. More specifically though, it's rotate towards target whilst attacking, because this is not going to be called unless you're actually in attack frames while you can rotate. So there's some special logic that needs to be met for this function specifically. And I'm giving it its own function also because I want to give it its own speed. Maybe you want some enemies to track with their attacks better than others, as in they can turn faster. So this is where you can handle that. So here's how we're going to do it. We're going to start by saying if our target is null, we're going to return. We can't process any logic without the target because we're using it to get our direction. And let's write some pseudocode right after that. So 1, we're going to check if we're allowed to rotate, if we can rotate. And then 2, we're going to rotate towards the direction of the target in respect to this character at a specified rotation attack speed and only during specified frames. So we're going to use animation events to open up these frames, and then during those frames you can track with the attack. So let's say if AI character dot can rotate, or cannot rotate, sorry, we're going to simply return. We don't want to do anything. Next, let's rotate towards the target. Okay, so how do we get our direction? We'll start off by making a vector 3. And we've done this many times before. It's the same thing that we always do. We take the position of our target. So in our case, that is literally our current target.transform.position. And we minus that from our position, which is the AI character.transform.position. Or the position of our AI character, rather. Next, we're going to take the direction and make the y equal 0 and then normalize it. We only want the directional rotation on the left and right. We don't want no upwards or downwards. Next, we're going to say if direction is equal to vector 3.0, we're going to say direction is equal to AI character.transform.forward. All right, now we use this direction to get a rotation using a quaternion. So we say quaternion rotation, and actually now I'm thinking about it, I'm going to call this target direction and target rotation, so the naming is a little bit nicer. This makes more sense to me. So target direction, and we'll call this target rotation, and this is very easy. Target rotation is just equal to quaternion.look rotation. So we just take a direction and look in that direction. Okay, perfect, cool. So now right under that, all we gotta do is apply this rotation with some speed. But you see there's the whilst attacking bit, so let's make sure we're performing an action to call this logic. So we're gonna say if the AI character is not performing an action, return. We only want to run this during the attack. If you want to be hyper specific, you can even give a flag to attacking only. But right now we're not going to do that because we don't need to. Let's keep it simple for as long as we can. So we're going to say AI character.transform.rotation is equal to quaternion.slurp between the rotation that it's already at by saying AI character.transform.rotation to the target rotation over a speed of attack speed times time.delta time. And we're going to call this attack rotation speed to be hyper specific. So let's give that its own header and its own value in the form of a float. So I'm going to come down right below detection, and you could technically put this on the locomotion manager if you wanted to, but it is specifically a combat rotation speed, so I'm going to keep it here. So I will say attack rotation speed is my header, then a public float attack rotation speed. I'm just going to say 25, a total random number right now. If you want to play with that, you can. See how it feels. I'm going to go back into the project, open up the data, go to the states folders, then right click AI states, and I was going to make my attack state, but we didn't give it a create asset menu. So let's go to the combat stance state and copy the create asset menu header here, and let's paste that on the attack state, and let's change combat stance to attack. And now let's try that again. We're going to go back into the folder, right click, create AI states attack. All right, looks good. So there's nothing here we need to change. We just need to simply add this state now to our dummy. So I'm going to say undead dummy. Could have sworn I called him undead dummy. Oh yes, I was only searching in data. Go to all, there he is. Okay, I got an error because netcode is bugged. I'm going to fix that right now. So if you're getting this error in the inspector and netcode is not showing 1.7 for you, type this into your add package by name. You can see 1.6 should change to 1.7.1. Yeah, there it is. Okay, so now it's updating. I'm going to snap back to the video in just a second when this is done. Okay, we're back. Now I am going to put in the combat stance state and the attack state. I'm not getting that variable any longer whenever I click an object with a network object script. So we go into the game here now. The character is locked in the pursue target state, won't change the state. So let's see what's going on there. Okay, yeah, we actually didn't finish our pursue target state when we made the combat stance state. We forgot to come back and add to it. So if we're within a combat range, switch to the state, the combat stance state. I'll show you two ways of doing this. The first one is if AI character combat manager distance from target is less than or equal to the AI character combat stance state engagement distance. Did I call that that? I think it's private or protected. Yeah, so let's make this public. So if it's less than the maximum engagement distance, you can switch to the combat stance state. Otherwise, method 2 is what I like a little bit more, and I'll explain why. So we're going to say return switch state AI character combat stance. So I don't like doing this because if you do it on the exact value of the AI combat stance state, then what happens is if you back up for a second, they instantly snap right back to the pursue target state. So if you keep going forward and backward, it can make them look kind of silly. So this isn't always the case though, but with some enemies it definitely is. What I like to do is option 2. I like using the nav mesh agent's stopping distance, because that's always where you're going to stop when you're chasing somebody anyway, unless you're an archer or something, but that's why I said it's very instance specific. So we'd reference the AI Character.NavMeshAgent.Stopping Distance, and then switch to the combat stand state using that. So that's what I'm going to do for most of my melee enemies. With hybrid enemies, I'll use a different approach. So we're on the combat stand state, but nothing is happening. So I'm going to quickly debug that too. You can see here I put some numbers here, 1, 2, 3, 4. It's really easy because I need it to get to 4. So if it doesn't get to 4, I know something's up. So okay, so we're getting to 1, 2, and 3. So what is the problem here? Let's go to 3 and see what it says. Okay, if I go to 3, it's get new attack. Cool, so I know that's the problem now. So let's go to get new attack, do the same thing. 1, 2, 3, and 4. And I'm at a 0 up here too. Okay, so the problem was I'm looking through a list. You can see here I declare potential attacks as a new list. And I'm looking through a list that I've just made. So I'm supposed to do a for each loop with AI character attacks, not potential attacks. So that's just a slip of the mind. So this should not be potential attacks. It should be AI character attacks. Okay, now before we go back, we also want to make sure we're calling our override reset state flags. Otherwise, once you perform an attack here, you're never going to reset has performed attack. So it's just going to skip out of the state and go back. So let's make has performed attack equal to false and has performed combo equal to false. And we're doing that on the override reset state flags. Now we go back into the project and run over to this gentleman. He's going to pursue me, pivot towards me here, and he gets close enough, and he is going to swing. Cool. Looks like it's working as intended. Let's just make sure he does both the attacks. Okay, so he's doing the same attack animation, and he's doing the same attack animation. The odds of it happening are getting very much slower every time he does it. Okay, there's definitely a problem here. So he's only doing the same attack animation over and over again. So let's do some investigating and see what's up there. Okay, so I've narrowed down the problem to the get new attack function, and specifically we're never returning out of this for each loop. So let's make sure when we get the attack, we return and end the loop. So I'm not going through the whole list every time. Let's save that, and now if we go back into the game, he should be performing both attacks. Should be selecting one at random and performing it. So get him to walk towards me, and that's the first attack again. Let's see. And that's the first attack again. Okay, if he does it again, it's still a problem. So let's see. Okay, no, there we go. He's playing the swipe. All right, so there you go, guys. We have an AI character now following us around. He's getting us as a target. He's following us around. He's entering a combat stance state, and he's attacking us. So in the next video, we're going to make it so this guy's attacks do some damage. We're going to assign him damage gliders. We're going to make it so the enemy can perform a combo. And we're going to make it so the enemy can track the character with their attacks during specific frames. That's the rotate whilst attacking function we just made. Alright guys, thank you very much for joining me. I hope you have a lovely weekend, and I will see you all next week.